This video is on solving quadratics by completing the square. So we're going to be solving by completing the square. There is actually a best time to use solving by completing the square. It's when your a value is equal to 1 and your b value is even. The reason why is because when you are completing the square, you have to divide by your a value to make a equal to 1. So if it's already equal to 1, that's already nice. And your b value, you want it to be even because you have to take half of b to complete the square. You're going to have to take half of b and square it. So if b is even, you can easily take half of it. So if it's not even, it's going to make a fraction. It's going to be a little more difficult. However, if the directions say to solve by completing the square, you still got to do it. So when completing the square, your directions may differ. So I actually have one problem and it's two different directions. So in this box right here, it's when your directions, it depends on your directions. So it depends on the directions. So I'm going to do this problem two different ways. So this is a recap of if it says to convert to vertex form by completing the square, I'm going to recap just completing the square. This one is the one we're going to be doing and we're going to be solving by completing the square. So I'm going to do a recap real quick on how to convert to vertex form by completing the square. So this is the problem we're going to do. So the one thing you have to remember when you're converting is, yes, it will be a y equals in the end, but you have to remember that if you divide, so if a is not 1, if you divide by a, when you're converting, you have to remember to multiply back by a when you're finished. So if you divide by a, you have to multiply back by a at the end. So we're going to take this problem. I'm just going to rewrite it as 3x squared plus 6x minus 12 equals to 0. So it is equal to 0 instead of equaling to y. We do have to put it back into y equals in our final answer. So to convert to vertex form, we have to divide by a. So I'm going to make a note that we are dividing by 3. That means I'm going to have to multiply back by 3. So I'm going to have my x squared plus 2x. I'm going to have plus a box because I know I have to end up moving my constant over, so I'm going to go ahead and do that. So I'm going to have plus 12, and I'm going to divide by 3, so I'm going to have a positive 4 plus that box. Then I'm going to take that half of b, and I'm going to square it. So I'm going to take my 2 divided by 2 and square it, which is equal to 1 squared, which is equal to 1. So I'm going to have that x squared plus 2x plus 1 is equal to 4 plus 1, because I'm putting that plus 1 into that box. This will factor to become x plus 1 squared will equal to 5. Now is when I have to remember to multiply back by that 3. Multiply back by 3. So I'm going to have 3 parentheses x plus 1 parentheses squared is equal to 15, because I have to multiply back to both sides. Then I'm going to subtract that 15 over to get it back to equal to 0. So I'm going to have 3 parentheses x plus 1 parentheses squared minus 15 is equal to 0. And then I have to convert this back into actual vertex form, meaning I have to have it as a function. So my answer will be y equals 3 parentheses x plus 1 parentheses squared minus 15. So actually my a value is 3. My vertex would be negative 1, negative 15. This is how we would convert it into vertex form. So that is just a recap of how to complete the square and how to convert back a quadratic from standard form into vertex form. Now, what we want to be able to do is to solve by completing the square, which is this way. So to solve, it's different. If you notice on this side, converting to vertex form, we actually moved everything back to the left-hand side of our equal sign, which is also one of the reasons why I put this on the left-hand side. On solving, we're going to have our x on the left, and we want to move everything to the right-hand side because we want to get x by itself. So in this case, when we solve, we still have to divide by a. So divide by a. We're still going to divide by a because we have to, but do not multiply back by a. So we will not multiply back by a. So we actually have to do less work because we don't have to multiply it back. So let's do this problem by solving. So we have the recap of actually doing completing the square. So we're going to follow the same steps, but in the end, we're going to move everything over to the right-hand side instead. So we have 3x squared plus 6x minus 12 is equal to 0. So I still need to divide everything by 3. So I just put 3, well, let's divide by 3. So I know we're going to have x squared plus 2x plus, we know we're going to have that box because we still have to do the same steps, is equal to, I'm going to have that 12 over here, divided by 3 is 4, plus the box. So we're still following the same steps as the first one. So now, again, still same steps as the first one. We want to take our half of b and square it. So 2 over 2 squared is equal to 1. Then we're going to square that is equal to 1. So we're still following that same step. X squared plus 2x plus 1 is equal to 4 plus 1. We're still going to factor this side, so this will still become x plus 1 parentheses squared is equal to 5. Now this is where we multiplied back by 3, but we're not going to do that. We do not multiply back by 3. This is where it deviates. Now our steps are different. This time, this looks just like when we solved by square roots. We're just going to solve this now. We only have one letter x in here, so let's just solve it for this x. Now we're going to use SADMAP. So I'm going to put a note over to the side. Use SADMAP. That's what we're doing now. So we need to add and subtract away first, which there's nothing added or subtracted to the outside. Multiply or divide, there's nothing multiplied or divided on the outside. So now we go to the exponent. We get rid of the exponent of squaring by square rooting both sides. So let's square root both sides. So when we square root the left-hand side, we have x plus 1 squared. That gets rid of the squared, which will also get rid of the parentheses. So we have x plus 1 equals. Now if we remember back to solving by square roots, on an equation, when you take the square root, you have to put that plus or minus sign in front of your value. Now, square root of 5 cannot simplify because 5 divided by 4 is a decimal. 5 divided by 1 is the only thing that works. 5 is prime. So we're going to keep square root of 5. So now we just have to start over with SADMAP. We have to add and subtract away from x. This time we just subtract that 1. So x will equal to, when we subtract that 1, we put it in the front of our plus or minus. We always put whatever we move over next in front of the plus or minus. We have negative 1 plus or minus the square root of 5. This cannot go any further. So technically our two answers would be negative 1 plus the square root of 5 and negative 1 minus the square root of 5. So to solve, we do not multiply back by a. So at that step, instead of multiplying back by a, we actually use SADMAP to solve for a. And this is how you solve by completing the square. You still do completing the square, but when we would re-multiply, that's when we completely change our directions.